Hello dear friends, welcome my channels. Today's discussions is integrations, complex analysis and complex analysis and hypergeometric functions. So friends, the first problem is the 0 to 1 minus x whole to the power 1 minus x divided by x whole to the power x by pi sin x dx. If you see this problem, it is very tough, but actually it is not so much tough, because if we will use branch complex analysis, branch cut method. So friends, our branch point is, if we observe, first I write the fz. Fz can be written this way: exponential minus iz plus z by pi log 1 by z divided by z pi z divided by pi log z. With minus pi less than argument z less than pi, or 0 less than argument 1 minus z less than 2 pi, and branch point at z equals to 0, 1. Take a branch cut branch cut 0, 1, this closed interval. Now fz becomes single values and continuous at c minus 0, 1. So integrate fz on a dog bone contour. This is the dog bone contour shown in figure. This is the figure shown in. We get fractional residue. We will write this is the gamma 1 and gamma Okay, and this point is AB, this is C, this is D, this is E, and this is F. So we get, using fractional residue theorem, gamma 1 comma gamma 2 fz dz equals to 0. Now evaluate integrals over upper and lower strips. So friends, I want to tell this is the upper and lower strips. We get integration upper plus lower fz dz is equal to 2 pi I residue z tends to infinity fz. So friends, we can write integration upper fz can be written 0 to 1 exponential minus ix plus x by pi ln 1 minus x minus x by pi ln x dx. Sorry, this is not upper, this is lower. And integration this is lower and this is upper. fz dz is equal to 0 to 1 minus exponential minus ix plus x by pi ln 1 minus x plus 2 pi I ln minus x plus 2 pi I minus x by pi ln x dx. Uppercase and lowercase. Now we will go to the next. So friends, I am talking about this upper strip and this is the lower strips. Difference is e to the power pi I. So we get minus 2i 0 to 1 sin x dx is equal to minus 2 pi I residue z tends to infinity fz. So minus 2 pi I and it can be minus minus plus residue z equals to 0 1 by z square f 1 by z equals to residue z equals to 0 1 by z square exponential minus I by z and pi root over z minus 1 whole to the power z. Because from these equations because if I will put in here f 1 by z, then what I get exponential I divided by z and plus 1 by pi z, and log 1 minus 1 by z plus 1 by pi z log z, and my calculation is wrong. It is not z pi z, it is not in here, it is in here pi z. So friends, this is my equations. Now friends, we have to find out the residue. So what is the residue? Actually you have to break this problem. I can write this way. You have to find out the coefficient of of 1 by z. When you get coefficient of 1 by z, the value will become 2 pi and 1 by pi plus 1 by pi square divided by 2 factorial up to this way we can get this series. We can get 1 by pi cube divided by 3 factorial, and we can get 1 by 2 pi exponential, it should be minus it should be minus. So exponential minus 1 by pi. This value we can get. If you will check, if we will expand this series, then we can get this value. I hope I can clear this concept very well. Next, number 2, question number 2. We start the solution. Fz can be written z root over z divided by 1 plus z square into root over 1 minus z. Fz can be written, and here this is the way it is moving. This is the way. This is the gamma 1. This is gamma 2, and this is gamma 1 and gamma 2. Fz. Here branch point of Fz at z equals to 0 and z equals to 1, and branch cut 0, 1. Fz is not continuous at the interval 0, 1. So at gamma 1 we have Fz equals to z to the power root over z divided by 1 plus z square root over 1 minus z. At gamma 2 Fz equals to z root over z 1 plus z square root over 1 minus z e to the power I prime. Gamma 1 comma gamma 2, gamma e to the power I theta, and mod of gamma less than epsilon and z tends to 0. So limit epsilon tends to 0, integration gamma fz dz equals to 0. Similarly, 1 minus z fz tends to 0 at z tends to 1. So this is the gamma 1. So limit epsilon tends to 0, integration gamma 2 fz dz equals to 0. So friends, we have zero to 1 fx dx is equal to minus pi I sum of residue So friends, here the residue is z tends to 1. You see that singular point z tends to 1, z tends to I plus minus I, and z tends to infinity. So residue at z tends to I fz equals to 1 by 2 into 2 to the power 1 by 4 e to the power minus 5 pi by 8 I. Just putting, how can I get that z minus limit z tends to I, z minus I divided by fz. You can get this value. After that, residue at z tends to minus I, we get 1 by 2 to the power 1 by 4 e to the power minus 3 pi by 8I, and z tends to 1, residue at z tends to 1 residue at z tends to 1 equals to 0, and residue at z tends to infinity fz equals to minus residue z tends to 0 1 by z square if 1 by z equals to I. This is the coefficient of the 1 by z. So we get the value 1 by 2 to the power 1 by 4 e to the power minus 5 pi by 8 plus e to the power minus 3 pi I by 8 plus I, and after that, after the simplifications, we get that 0 to 1 x root over x divided by 1 plus x square root over 1 minus x dx is equal to pi minus pi by 2 minus pi by 2 root over 1 plus root over. So friends, again we will see fz cube root of z 5 minus z whole cube divided by 1 plus z. Here branch point are at z equals to 0. Here branch point are at z equals to 0, comma 5. So take a branch cut on 0, comma 5. Take a branch cut on hence function is analytic. Function is analytic at complex. This is the theorem number 3. Sorry, question number. Complex plane except 0, 5. So our contour looks like a dog bone. This is the our contour. So friends, whatever we get, we can again write it is A, it is B, it is new 1, it is new 2. So integration A plus integration B and plus gamma 1 plus gamma 2 total fz dz is equal to minus 2 pi I residue fz plus residue z equals to minus 1 fz. So gamma 1, gamma 2 are circles around respectively, and this portion is 0, and summation A fz dz fz plus this is and this is upper portion is the exponential of 4 pi I divided by 3 multiplier 4 pi I divided by 3 multiplier. So we can write this way: 1 minus e to the power 4 pi I divided by 3 0 to 5 and fz dz equals to 2 pi I exponential and this is the z tends to z equals to infinity, so exponential 2 pi I divided by 3 into 13 by 3 because residue z tends to infinity, fz equals to minus residue z equals to 0 1 by z square f 1 by z equal to 13 by 3 e to the power 2 pi I divided by 3 and residue z tends to minus 1 fz two pi I divided by 3 cube root of 36. So this value is become, we can write so we can get this value. This is the answer of this integrations. Now we shall go to solve this problem. This problem is very important, hypergeometric problem. So at first I shall divide it into two parts. This is part 1, this is part 2. So for part 1 we can write this way: summation n equals to 0 to infinity 1 by n gamma n plus half divided by n factorial whole square. It can be written summation, it can be written n equals to 1, summation n equals to 0 to infinity 1 by n plus 1 gamma square n plus 3 by 2 into gamma square n plus 2. So friends, because I just change the scale, n equals to 1 to infinity, n equals to 0 to infinity, 1 by n plus 1 and 1 by n plus 2. And after that we can write summation n equals to 0 to infinity gamma square 3 by 2 plus n gamma n plus 1 gamma n plus 1 into 1 to the power n divided by gamma square n plus 2 gamma n plus 2 n factorial. We know that summation n equals to 0 to infinity gamma n plus e gamma n plus p to gamma n plus q plus gamma into gamma n plus f divided by gamma n plus c gamma n plus d and gamma n plus e. So it can be written this way: gamma a gamma b gamma q gamma f divided by gamma c gamma d and gamma e 4 f3 abq f comma cd comma e. Here, if we will comparing with this, here a equals to b equals to 3 by 2, q equals to f equals to 1, c equals to d equals to 2, and c equals to 1. We get the value is gamma square 3 by 2 4 f3 3 by 2 3 by 2 1 comma 1 comma 2 comma 2 comma 2 comma 1, and this value is pi by 4 f3 3 by 2 comma 3 by 2 comma 1 comma 1 comma 2 comma 1. This value we know that pi by 4 16 log 2 minus 2g divided by pi. So this value is log 16 to the power pi minus 8g. Next is part 2 for part 2. For part 2 we have summation
1 by n gamma n plus 1 divided by gamma n plus 3 by 2 whole square. It is can be represented this way: n equals to 0 to infinity gamma square. Friends, I just calculate. You will calculate this in yourself. Then you can get this way: gamma square n plus 1 gamma n plus 2 into gamma square n plus 5 by 2 1 to the power n divided by n factorial. And it can be written this way: gamma square 2 gamma square 1 into gamma square gamma 2 into gamma square 5 by 2 4 gamma 3 2 comma 1 comma 1 5 by 2 5 by 2 comma 2 comma 1. And this value can be written this way: 16 divided by 4 pi 3 gamma 2 1 comma 1 comma 2 comma 5 by 2 5 by 2 comma 1. And it can be written 16 divided by pi minus 4 after putting this value. So my answer is in here. ln 16 whole to the power pi minus 8g divided by 16 divided by pi minus 4. Now friends, our discussion is based on elliptic integral. So kx can be written this way: summation n equals to 0 to infinity double bond divided by 2n double bond whole square x to the power 2n dx. So friends, and another is pi by 2. So friends, it can be written this way: pi by 2 0 to 1 1 by root over 1 minus x summation n equals to 0 to infinity 2n minus 1 double factorial divided by 2n double factorial whole square x to the power 2n dx. Again, you can write this way: pi by 2 summation n equals to 0 to infinity 2n minus 1 double factorial divided by 2n double factorial whole square and 0 to 1 x to the power 2n divided by root over 1 minus x square dx. And this is the beta function. It can be written this way: pi by 2 summation n equals to 0 to infinity 2n minus 1 double factorial divided by 2n double factorial gamma n plus half into gamma half divided by gamma n plus 1. This is beta function. Beta n plus half comma half. Now friends, you have to remember that 2n minus 1 double factorial equals to 2 to the power n gamma n plus half divided by root over pi, and 2n double factorial to the power n divided by n factorial. Summation n equals to 0 to infinity gamma n plus half gamma 1 by 2 half to the power 2n gamma square n plus half divided by 2 to the power 2n n factorial whole square gamma n plus 1, and it can be represented this way: gamma cube 1 by 2 root over pi by 4 summation n equals to 0 to infinity 1 by 2 whole cube n 1 square n factorial. So friends, this is the Watson summations theory. Watson summation theorem 3f2 a comma a comma a comma 1 comma 1 comma 1 equals to gamma 1 minus 3a divided by 2 cos pi by 2a divided by gamma cube 1 minus a, and it can be written this way: gamma cube 1 by 2 pi by 4 3f2 half comma half half 1 comma 1 comma 1, and this value is become, just putting this value, whatever I get we just putting this value is gamma 3f2 half comma half comma half 1 comma 1 comma 1 comma 1 equal to gamma 1 by 4 cos pi by 4 divided by gamma cube divided by 3 by 4. Okay, just putting this value in here and get the answer. I hope I can clear total. So friends, my answer is final answer is pi cube divided by 4 gamma cube 3 by 4. Let's start to discuss this problem. Ramanujan Master's theorem. I use Ramanujan Master's theorem. So friends, my Ramanujan Master's theorem states that if a function has expansion of the form of fx equals to summation n equals to 0 to infinity psi n divided by minus x whole to the power n divided by n factorial then the milling transformation of fx is given by zero to infinity x to the power n minus 1 fx dx is equal to gamma a into psi. So here we can see that k into power minus x can be written this way: pi by 2 summation n equals to 0 to infinity divided by 2n factorial divided by 2 to the power 2n n factorial whole square minus x to the power n. Therefore phi n is equal to pi by 2 2n factorial whole square divided by 2 to the power 4n divided by n factorial whole cube. So as per Ramanujan Master's theorem, theorem 0 to infinity x to the power n minus 1 k root over minus x dx is equal to gamma a into psi minus e is equal to pi by 2 gamma a x to the power a minus 1 gamma a and 1 minus 2a factorial divided by 2 to the power minus 4e, I write some mistake, minus e, psi minus e. This is the Marin transformations. So 2 to the power minus 4a minus e factorial whole cube. And now it can be written this way: pi by 2 to the power 4a gamma a gamma square 1 minus 2a divided by gamma cube 1 minus a, as for all a belongs to 0, half. If a equals to 1 by 4, then 0 to infinity k root over minus x divided by 4x cube dx is equal to pi cube root over 2 gamma cube to the 3 by 4. I hope I can clear this concept. Thanks for watching, friends.